Alright, for this one, I would first start by getting everything on the same side of the equals mark. So I would subtract 8 from both sides of x to the 6 minus 7x cubed minus 8 equals 0. Now I'm going to figure out what I need to do to make it look like it's a quadratic. My quadratics would look like x squared minus 7x minus 8 equals 0. So if I substitute x cubed for x, then if I square x cubed, I do get an x to the 6. If I square x cubed, I'll get an x to the 6. If I put in x cubed for x here, I will have a 7x cubed there. So that is an appropriate substitution. So on this one, I just need to see about factoring it now, because it looks much more like what we're used to, factoring. So I need my x's to factor, and I am looking for factors of 8 that differ by 7, and those are 8 and 1. And I want it to be a negative 7, so I'll put the minus sign with the 8. So now I've got it factored. And I'll check real quick. I do have x times x for my x squared. I do have 1 times negative 8 for a negative 8 at the end. And for my middle terms combined to make that one, so I checked those. I've got x and a negative 8x, which add up to a negative 7x in the center. So I know that I've got it factored correctly. So after I solve each of these, set each equal to 0 and solve, I've got x is equal to negative 1, and on this side, I have x is equal to 8, and I have messed that up a little. So x minus 8, I got ahead of myself, equals 0, so I'd add 8 to both sides, and x is equal to 8. Now I've got to substitute that back in, because I said x was equal to x cubed. So since I said that I found x to be negative 1, so negative 1 is equal to x cubed. And I found x could also be 8, so I do 8 is equal to x cubed. And then I solve those. So I'll take my cube root of each side, and I'm kind of just doing it on both of these equations at once. Sorry about that. But if I take the cube root of x cubed, I just get an x, and the cube root of negative 1 is negative 1. It's negative 1 times negative 1 times negative 1 gives me negative 1. So that's its own cube root. And for this one, x is equal to the cube root of 8, which is 2, because 2 times 2 times 2 will give me 8. So these are my solutions. On this problem, you are very close. You missed the sign on the second one, and I have these as x's instead of u's. I haven't substituted yet, but anyway, I've got that in there. And the second part of that is to take that, because I let this thing be my x. X was equal to 1 over 3k minus 4. So now that I know what my two x's are, or you use u's, that's perfectly fine, and that's probably what they have in the book. I tend to use x's. But anyway, I'm going to substitute my negative 1/2. I'm going to plug that in for my x, because that's what I found to be x. And that is equal to 3k minus 1 over 3k minus 4. Now, this one reminds me of a proportion, in which case I could cross multiply. And that's probably the simplest way to work it, too, is to cross multiply. And when you do that, you can leave the negative with the numerator. That's easier to do that way, too. So, if I leave my negative 1 with the numerator and cross multiply, negative 1 times 3k minus 4 is equal to 2 times 1. So I'm going to distribute my negative 1 and make it negative 3k plus 4 is equal to 2, and then I will solve. So if I subtract 4 from both sides, I have negative 3k is equal to negative 2, and then divide by negative 3. So k will be 2/3. And then I'll do the exact same thing, except my other x was equal to negative 2, so I set negative 2 equal to 1 over 3k minus 4, and I'll solve that one as well. And this time I'll just stick the negative 2 over 1 so I can do the proportion thing again, because again, that's the easiest way I know to multiply that and solve. So negative 2 times 3k minus 4 is equal to 1. So I'll distribute my negative 2 and solve. So I can subtract 8 from both sides. And negative 6k is equal to negative 8. Oh, not negative 8. It is 1 minus 8, so negative 7, and then divide by negative 6. So k would equal 7, 6. So those are your two solutions for this one. I don't think the one that was in the homework was quite so bad as this, and I try not to put one that was quite so bad. But this is the same procedure that you would use after you've decided what you're going to use to substitute. After you've solved, you take those and set it equal to your expression that you were substituting for. So I hope that helps.